lecture is 1.2. As you know that I told before in the lecture outlines that the second point which I will describe is that how to begin with quantum mechanics. So now the next question we have, how to begin, means how to start the quantum mechanics. You all know that it is too much difficult to start quantum mechanics because the different books uses different methodologies. So therefore, for me, the easiest one means the collection of all points. For me, I want that the most easiest point will be that I should start the quantum mechanics by the property of linearity. Property of linearity. So this will be very helpful because this is the mathematical approach, and hence you all know that quantum mechanics is actually the mathematical description of the physical world. So therefore I have to choose the property of linearity. The main question that should arise in your mind is that why did I choose this property? Means why did I choose this topic, the linearity, the start of the quantum mechanics? So my dear students, the main reason is because the property of linearity tells us that what kind of theory quantum mechanics is and why. That is why I choose the property of linearity. What kind of theory quantum mechanics is and why. So therefore I choose linearity property, the beginning or the start of quantum mechanics. So let's carry on. The next we have regarding means related to the same thing, that is the linearity of equation. Linearity of equation of motion. Equation of motion. So dear students, you have to remember a point that in physics usually a theory is described by a set of equations for some quantities. We call that the dynamical variables for theory. This is the very important point which will help us in the upcoming topics. Dynamical variables. Now, the most important point you have to remember always and you have to keep in mind, that is in quantum mechanics, whenever you have any theory, you have to explain that theory with the help of mathematical equations, and then that equation will be having a solution. This is the most important point. The mathematical equation will be having the solution. Now the question is, what did the solution tell us? Yeah, what is the significance of solution? Why we need the solution of any equation which describes that particular theory? So now this is the most important question. Means that significance of solution. Significance of solution. So dear students, remember always that solution tells us the possible reality according to that theory. The most important significance of solution is, the aim of solution is that it actually tells us the possible reality according to that theory. Like for example, I want to give you a very simple example. Expanding universe is the solution of Albert Einstein's gravitational equations. And similarly, a single theory may have different solutions, and each solution describes the possible reality according to that particular theory. So that is the most important point regarding the solution, and that is the answer to the question that why we need the concept of solution for any equation which describes the particular quantum theory? So the answer was to study the possible reality. This is the why. The possible reality according to theory. That is why we sometimes need the solution of any particular equation. Now we have to move ahead. The next point regarding the same is about the linearity theory. We have to carry on about the same topic. Now the next very important point is the linearity theory. Means the same thing is only a bit explanation it needs. Linearity theory. Now, my dear students, the most important point is that what is the remarkable fact about the linearity theory? Remarkable fact. Remarkable fact according to linearity theory. Dear students, the remarkable fact of linearity theory is that if you have two solutions, you obtain a third solution by simply adding the two solutions. This is the most important remarkable fact about the linearity theory. I will revise again. If you have two solutions, you obtain a third solution by simply adding the two solutions. So that is the most important fact about the linearity theory. A very beautiful example which I want to give according to the same theory, the same property to which I have started my lecture. So the most important and the very beautiful example is actually the Maxwell's theory of electromagnetism. Very important. Maxwell's theory of electromagnetism. Maxwell's theory of electromagnetism. Now the most important point is that why we need the concept of Maxwell's theory of electromagnetism. This is the most important point. So to the point answer is because the Maxwell theory, this theory governs the behavior of electric and magnetic field. That is why we need the concept of Maxwell's theory of electromagnetism. Now, if I have to explain the Maxwell theory, means you know about the field. Field is actually a quantity which depends upon the position, which depends upon the time. So that is the function of time and position. So that is about the concept of field. But we have not to go through in many details. Now the next point, Maxwell's theory of electromagnetism. This is one of the very best example of linearity theory to which I can apply the linearity property. So how I can apply the linearity property to the Maxwell's theory of electromagnetism? For this I have to choose 2 points. The first point, I have to explain this practically, and then I have to explain it mathematically. So now let's take the first part, that is practically. And it is too much important topic, you know, about the electricity and magnetism. So like for example, you all know that practically the solution of Maxwell theory that actually describes the propagation of electromagnetic waves in a particular direction. Like for example, the electromagnetic waves propagating in one direction, this may be a solution, and there may exist another solution as well, that the electromagnetic waves moving towards you, propagating towards you, this is also a solution. And there may be the consistent solution that the electromagnetic waves are moving, propagating simultaneously. their sum may also be the solution. This is the very important point regarding the solution of Maxwell's theories of electromagnetism, and that is the practical example which I described. You know about this in a very better way, that our air is filled with thousands of electromagnetic waves, and all the electromagnetic waves are propagating simultaneously. They do not interfere each other. They do not interact each other. The simplest example is you have a phone calls. Now the phone calls, we have the TV channels, we have the cables, we have, and the same is the case, the net we have. Now these all are propagating the electromagnetic waves. The electromagnetic waves are traveling in the atmosphere, but they do not interfere each other, even though they are propagating simultaneously. So that is the very remarkable fact regarding the linearity theory on the basis of Maxwell's theory of electromagnetism. Now this was the practical approach. Now we have the mathematical approach. Mathematical approach. Now my dear students, the mathematical approach to the Maxwell's theory of electromagnetism is, you all know that Maxwell's equations are actually the linear equation. Means their solution is described by the dynamical variables. I mean that Maxwell's equations are actually the linear equations, and their solution is described by the dynamical variables. Dynamical variables, which I told before. Which variables we have? We have E, the electric field, or we have B, the magnetic field, or we have rho, the charge density, or we have J, the current density. These are the dynamical variables which actually describe the linear equation, means the Maxwell equation. Now, if E, B, rho, J, if this is the solution, if this is the solution, then according to linearity, now here I will also use the two approach. One is scale by scalar, and the another one is by the two solution forms. So the first one is scale by scalar. It means that if you multiply these dynamical variables which we assumed the solution of the Maxwell theory, then if you multiply E, B, rho, J by any constant, let's call that constant alpha. Alpha E, this is the new electric field. Alpha B, this is the new magnetic field. And alpha rho, this is the new charge density. And alpha J, this is the new current density. So this will also be the solution according to the linearity property. Is also a solution. So this will also be the solution according to the linearity property. This is the new electric field, new magnetic field, and the new charge density, the new current density we have. Now the second one is the solution, the two solution forms according to linearity theory. So let's come that according to that. I think I should erase this because we do not have the place here to write. So my dear students, the two solution forms. The two solution forms is in a sense two solution forms. Like for example, we have E1, B1, rho 1 and J1. E2, B2, rho 2, J2. You have to put this, the very important point here. Now, the two solution forms is in a sense if this is a solution, then according to linearity, their sum will also be the solution. As I told before, their sum will also be the solution of Maxwell's theory. How? Like this, E1 plus E2, and the same is the case B1 plus B2, and rho 1 plus rho 2, J1 plus J2 is also a solution. According to what? According to the linearity property, which I described before as well, that according to the linearity theory, that their sum may also be the solution. Now, these are actually the examples related to the linearity property. But now the question arises in your mind that what is the precise meaning of the linearity equation? How I can write the linearity equation in the general form? So let's come now the general form and discuss the general form. So here I have to write so dear students, now we have the general form. General form of what? General form of linearity equation. The general form of linearity equation is LU is equal to 0. Now here L is actually the linearity operator. Which is acting on U. U means the unknown. Now what that unknown may be? That unknown may be the position of time. That may be the position. That unknown may be a function of time. That unknown may be a function of position. That unknown may be a function of both position and time. So this is actually the general form of the linearity equation. Now my dear students, this equation has to be followed by the two properties. Like for example, we have the first property regarding this. Two properties regarding this we have. The first property we have, that is LU1 plus U2, mean any unknown, any two unknowns. This will be, the linearity will apply here as well, the linearity will apply here as well. LU1 plus LU2. And the same is the case. The second property for this we have that is in a sense, like for example, if you have L, if it is operated, means because it is the linearity operator, if it is operated on any constant which is with the unknown, like for example we have U, this is the simplest one, then alpha L U. Clear? So then it is then the form will be like this. Now here alpha is actually a constant. It is a constant, and that constant may be any real number, belongs to any real number. So this is actually the general form of linearity equation. Now my dear students, if U1 and U2, if U1 and U2 is a solution, if U1 and U2 is a solution, what does it mean? Such that LU1 is equal to LU2 is equal to 0. Then alpha U1 plus beta U2 will also be the solution. Clear? So this is the very important point. Now to this general form, I want to give a very best example by which you will understand in a very precise way. So let's have the last example of this lecture. That example is actually related to the linear differential equation. Like for example, we have du by dt plus 1 over tu. Now this is a linear differential equation. Linear differential equation. Now I took this example, means this is one of the linear differential equation example for the linearity theory. Now if someone asks you that how you can treat this linear differential equation on the basis of linearity theory, on the basis of linearity property, so then the most important approach is that Lu is equal to 0. Now now someone can ask that what did you choose here here L? Now here L is actually defined as, I want to define L as d by dt and plus 1 over t. This is actually L, and it satisfies the same property of the linearity equations which I discussed here now. The two properties, one is the sum property and one is the product property. Means like Lu here you will be having, for example, you have to check by yourself. If you put here u, then you will obtain the same thing. So this is the most important concept of linearity equation. So my dear students, the summary of our today's lecture is that we discussed the beginning, means how to start a quantum mechanics. Now we started the quantum mechanics by a very best approach, and we call that approach the linearity property, and then we discussed the linearity theory and some mathematical approach, some practical examples we discussed here. So I hope so that you may have gone through a very precise lecture. Inshallah, in the upcoming lecture we will explain, we will be having a practice problem on these linearity equations. So see you in the next lecture.